Yaskawa.
Welcome to the MP3200iec Hardware Overview e-learning module. Hi, my name is Matt Pelletier, and I'm a product training engineer for Yaskawa Motion Control and Servo products. I'll be your instructor for this e-learning module. In this training module, we'll overview the basic features of the MP3200iec. Then we'll go through the front panel, discuss Mechatrolink 3 network, Ethernet communication, programming, and finish with a few frequently asked questions. The MP3200iec is designed for extreme performance in the most demanding applications, such as printing, converting, packaging, or any application that requires a high number of axes along with fast network and PLC scan times. It is currently the performance leader in Yaskawa America's offering of MP-IEC controllers. By measurable performance metrics, it is 4 times faster than the MP2300iec controllers and 8 times faster than the single-axis MP2600iec. This performance advantage exists thanks to a 1 GHz 64-bit processor, up to 8 slots of I/O, and the ultra-fast Mechatrolink 3 motion and I/O network. You can see from the table below that the MP3200iec can easily handle up to 4 servo axes at 0.25 milliseconds. Even at the maximum of 62 axes, the network still updates at 4 milliseconds. A typical system configuration is as follows. The Mechatrolink 3 motion and I/O network connects Sigma 5 servos and Mechatrolink 3 I/O. Switches, sensors, relays, indicators, external encoders are all connected through the local I/O modules. All other connections are made through Ethernet. HMI, third-party I/O, and PLC are connected using the communication protocols Ethernet IP and or Modbus TCP. Connections to a PC are made with OPC server or the web server, and the MP-IEC controllers support all these connections at the same time over the same ports. The MP3200iec consists of 3 basic units. The power supply and the CPU together comprise an operable system. Add the option base and the user-installed I/O in each slot to make a system complete with inputs and outputs. These pieces connect and lock together to make one customized machine controller. Now let's take a look at the front panel and connections for each of these units, starting with the power supply. There are 2 different power supply units, the AC 110 220 volt and the 24 volt DC unit. The input voltage is printed next to the connector. Power on is indicated by the green LED. Medium and high output load level is indicated by the yellow and red LED. And in the middle is the relay out connection. This connection is closed when the CPU is in ready status, as indicated by the ready status LED. This way, the controller's ready status can be directly wired to external control circuitry. Now let's look at the CPU unit. At the top is a simple 7-segment display which can show the controller IP address when powered on with the test dip switch on. To the right of the display you see status LEDs. These operate the same as the other MP-IEC controllers with indicators for ready, run, alarm, error, low battery, and Mechatrolink alarm. The rotary switches set the last byte of the IP address override. This address is selected when the controller is powered on with both EINIT and EPM0 dip switches set on. The MP3200iec has a few more dip switches compared to the other MP-IEC controllers. Details on the dip switch function can be found in the manual. The OP port is for factory use only, and for this reason has a clear protective cover in order to prevent user connection. 2 ports are available for Ethernet connection to the controller. Unlike the single-axis MP2600iec, these ports are connected internally as a hub. The controller has just 1 IP address. Finally, at the bottom left, we have 2 connections for the Mechatrolink 3 motion and I/O network. The included memory backup battery is located inside the bottom of the CPU unit. This battery is required to store variable data, alarm history, and calendar when power is off. The battery is good for about 1 year of cumulative power off time. And when the voltage of the battery is low, the BAT LED will turn on, and it's time to replace the battery. The empty option base can be selected with 3, 5, or 8 slots according to the required I/O capacity. I/O cards such as the LI001 are selected and individually installed, creating a machine controller customized for the application. Cards can be removed using this small tool built into the front of the option base. The MP3200iec supports the same option cards as the MP2300iec controllers. The LI001 and LI002 provide 16 digital inputs and outputs along with an external encoder input with high-speed latch. For higher onboard I/O count without the external encoder input, consider using the LI004 or LI005 with 32 digital inputs and outputs. For a solid mix of I/O capabilities, the LI006 offers 8 digital inputs and outputs, analog input and output, and encoder input with high-speed latch. Also available are dedicated analog input and analog output. 64-point digital output is available on the D001. And Ethernet communication can be expanded using the 218IF-Y1. This card also provides serial communication. Wiring to the I/O cards is accomplished through breakout cables with terminal blocks. Terminal block conversion kits are available for the LI001, 02, 04, 05, and 06, as well as for the servo amplifier I/O connector. Mechatrolink is the network of choice for Yaskawa MPIEC controllers. It's an open, high-speed, deterministic motion and I/O network optimized for electrically noisy factory environments. The MP3200iec is optimized for the high-speed communication of Mechatrolink 3. Operating over the Ethernet physical layer, it provides network communication cycles as low as 0.25 milliseconds. The feature that sets Mechatrolink apart from other motion and I/O networks is the capability for data retry within the same network communication cycle. You can see here in MotionWorks IEC, Mechatrolink 3 configuration, the max retries setting. Here's how it works. If, for example, the response message from slave node 1 were corrupted due to electrical noise, there is, within the same communication cycle, a second chance for the data to be received. Data retry greatly reduces the possibility of data loss in electrically noisy environments, such as the plant floor, thereby ensuring consistent and reliable performance of Mechatrolink servos and I/O. While all versions of Mechatrolink support data retry, this table summarizes a few of the key improvements in Mechatrolink 3 over Mechatrolink 2. Most notable is the baud rate, now 10 times higher at 100 megabits per second. The network cycle time can be as low as 31.25 microseconds, although for practical purposes on a multi-axis system, the MP3200iec controller supports cycle times starting at 250 microseconds. The maximum number of nodes is now 62, with a longer max distance between stations now of 100 meters and no minimum limit. Running on Ethernet Cat5 cable, several connection topologies are supported by Mechatrolink 3, which will be illustrated next. Network topology defines how the devices can be physically connected together. The devices are commonly referred to as the network master and slave nodes. In our case, the master is the MPIEC controller, and the slaves are the Sigma 5 servo amplifiers. Your normal cascade topology simply connects the devices one to another. Since each device retransmits to the next device, star topology offers the fastest network response, but requires another device called a hub, a central point that connects the nodes together, transmitting simultaneously. These topologies can be combined as required. For more complex topologies, network times can be modeled using the Mechatrolink 3 utility software, available for free from mechatrolink.org. The MPIEC controllers support a wide range of Ethernet communication options. Through PC communication, we can use MotionWorks IEC programming software, access the internal web server, or set up an OPC server to access variable tags. Third-party devices can interface using Modbus TCP and Ethernet IP protocols, and any other type of data transfer can be accomplished using custom protocol. All MPIEC controllers have a web server, an interface which is built into the controller itself. Connect the PC to the controller, enter the controller IP address in your browser, and the web server gives you access to many of the critical functions of the controller. No software on your PC other than Internet Explorer and Java 6 is required to access the controller's internal web server. Lots of troubleshooting and maintenance can be accomplished directly through the web interface, even on a computer that doesn't have MotionWorks IEC installed. You can troubleshoot and clear alarms, view alarm history, monitor and graph motion and I/O, even test servo motion, set and restore servo parameters, and back up or restore the project. You can do with the web server pretty much everything except to edit and monitor the code itself. Passwords can be configured to control access to the various functions of the web server. If necessary, the controller firmware can be upgraded in the field. For more details on how to use the web server, documentation is available within MotionWorks IEC and also online. OPC, OLE for process control, is yet another communications option over Ethernet. OPC is a widely used standard communication interface for factory automation. Once you have Yaskawa's OPC server software running on a PC in the network, you've opened the gateway to real-time communication between the machine process and the factory network. For an overview and demonstration of OPC server, check out the e-learning video. From the single-axis MP2600iec to the MP3200iec with 62 axes, all the MPIEC controllers program and operate on one common platform. That means one common programming software, MotionWorks IEC, just one set of PLC Open Motion instructions or motion libraries. The same libraries of application toolbox code from Yaskawa works with every controller. And if you can reuse our code, you can reuse your own code from one application to another and from one controller to another. Whatever application knowledge and code you've written in one MPIEC controller can be scaled up to the MP3200iec, and code you develop for the MP3200iec can be scaled down for use in the others. This means that machine designers can create code libraries and scale their control systems to meet the level of automation the customer is able to invest in. It's one control platform and one software environment for single or multi-axis. Now for a few frequently asked questions. Some have asked if the MP3200iec can be used with Mechatrolink 2 servos. While some of the features such as data retry exist on both Mechatrolink 2 and 3, the networks are quite different and not interoperable. The high-performance characteristics of the MP3200iec are optimized for use with the high-speed communication of Mechatrolink 3 only. What about the USB port? The USB port and corresponding Stop Save button will allow a project to be loaded or the firmware to be updated without a computer, perfect for easy maintenance and program upgrades. This feature will be supported in a future firmware release. What version of MotionWorks IEC do you need for use with the MP3200iec? You do need version 2.4 or higher. You can download the latest version from yaskawa.com. Are there any new features related specifically to the MP3200iec? While programming is identical between MPIEC controllers, the differences in hardware can be seen in the configuration. First, you'll notice that the node number and logical access numbers begin at 3 rather than at 1. This is simply characteristic of Mechatrolink 3. More importantly, however, each Mechatrolink 3 node has the configured response time setting, which can be set to default, measured, or maximum. These settings comprise the communication cycle usage, as displayed graphically. Find quick start videos on these and many other how-to topics on the product homepage. Another important feature is the ability to simultaneously capture two positions from the same servo axis at high speed. For the programmer, this means that two MC touch probe blocks can be executed at the same time on the same axis. Thanks to Mechatrolink 3, 1 or 2 input sensors can be used to latch positions and maintain synchronization in web handling applications. For example, a sensor can be used to detect a product as it moves by, and the length of the product can be accurately measured using the positions captured at the rising and falling edge of the sensor. Another feature in the hardware configuration is the ability to copy axis parameters from one servo to another, making it simple to configure axes that are the same. It's also easy to set specific parameters simultaneously on multiple axes in order to configure the hardware quickly and accurately. This feature is also available for the other multi-axis MP3200iec controllers. This concludes the e-learning module. Thanks for watching, and please feel free to contact the Technical Training Services Group of Yaskawa America with any and all comments and questions. Thank you and have a great day.